Hey everyone, welcome to today's Tech Talk. My name is Iftekhar Uddin. Today we'll talk about database management. So yeah, this is our agenda. Specifically, we'll talk about three concepts. We'll talk about sharding, failover, and recovery. Now, these topics are huge, and in the interest of time, I'll provide a broad introduction today. But if anyone wants to discuss them further, you can reach out to me after the talk. Sharding. All right, let's talk about sharding. So sharding is basically splitting your data across multiple databases and servers. It's like an optimization technique to achieve horizontal scalability in databases. So say you have an app and your app's like database currently stores 1 million users and its capacity is say 256 gigabytes. Now your app is becoming very popular, congrats. And so you see an increase in the number of users to 2 million users. So what you do is you increase your database size to 512 gigabytes. You've essentially tried to scale up your hardware. Now, so there are 4 million users. You increase the database size again to like 1 terabyte. Now, this is the max you can have in one database server. Let's say you can't increase the storage capacity of the server beyond this. So what will you do? Like say when you have 8 million or 60 million users, well, what you could do is you can divide this data into multiple databases. All right, so like say now you have like 4 1 terabyte databases, and each of them will have stored like 4 million users. So basically you have divided your data into different parts or shards, and all of them combined represent your complete data set. So let's see how data can be divided in sharding. So here we have a table with 4 rows of data and 4 columns, and this is in one database entry. So if we shard it, and if you look at the horizontal shards on the right side, we see 2 shards, HS1 and HS2, and you can see that the table was split by rows, with rows 1 and 2, Bob and Fred are in shard 1, and rows 3 and 4, Muhammad and David in shard 2. And again, these 2 shards will be in different databases. And on the left, we have vertical sharding. Here, the data was split vertically by the columns, with VS1 having first and last names, and vertical shard 2 having the city information. Horizontal sharding is more popular than vertical sharding. And so whenever I say sharding, I'm mainly referring to horizontal sharding. All right, so sharding has a number of advantages. One is horizontal scalability by increasing our overall storage capacity. As we just saw, we couldn't store all of our data in a single database, right? And by partitioning our data into a number of shards, we were able to then store all of our data. Another advantage is faster queries or query optimization. Say, if we had all 16 million users in one database and we had to run a search query, the query then has to go through all 16 million rows to fetch that data. So the query would be slow. But if the data is divided into 4 shards, then the query can be directed to one particular shard. For example, let's say we're looking for a user ID between 1 and 1 million, and that shard 1 stores the first 4 million users. So we can then directly send the query to shard 1. And now that query only has to scan a quarter of the data, which will make it faster. Another advantage is availability and fault tolerance. So say if you have all your data in one database and then this database fails, you will then lose all your reads and writes because it's a single point of failure. But if you have 4 different databases and one goes down, then you lose only a quarter of your data. The other 75% will still be there. All right, let's talk about the disadvantages of sharding. First is non-uniformity of your data. You want to split your data evenly across the shards, but what if like one user or customer is a large customer who has tons of data on your app? What can happen is your shard sizes, they can become different from one another. So like say, depending on the key you're using, like in this case, for example, customer ID, you can like have uneven storage of your data and the size of your shards can become disproportionate to one another. So what will happen is like queries going to like shards with a lot of data, they'll become slow since that partition is like overloaded. Another disadvantage is it might not be suitable for analytical style queries. Say if you have queries that require joins from different shards. For example, if you want all users, say all 16 million users, then the query needs to search through all 4 shards. It has to go through the first shard, then it has to go to the second shard, and so on. Then combine all the data and then get back the results. This will take a lot of time and will be expensive. The other disadvantage is that once you've sharded, it'll be really hard to go back to the non-sharded architecture. It's basically a one-way road. So once you've sharded, you're kind of done. So think very carefully before sharding. In general, like everything becomes more complex with sharding. Like implementing and deploying your database gets a lot more complex. So there's failovers and like backups and other kinds of maintenance. So like essentially, you should only use sharding when you absolutely have to. Now, some of you might wonder that the stuff we talked about sharding, they sound a lot like horizontal partitioning. And you'd be right, because horizontal partitioning is similar to sharding in that you are splitting, say, a big table into multiple tables. But the difference is horizontal partitioning splits the big table into multiple tables in the same database. Whereas sharding, it splits the big table into multiple tables, but across multiple databases. So single database versus multiple databases. All right, let's talk about failover. So failover is when the primary database fails and a standby database takes over the primary role. It's like performed only in the event of a catastrophic failure, like of the primary database, and it may result in data loss. So let's go through a failover process. If you look at the leftmost image, there are three things. An observer and two databases with their servers. The left one is the primary database and the right one is the standby. The observer essentially monitors the primary and the standby, and it ensures that both systems are running. Now, if something happens to the primary database, say it becomes corrupt somehow, like in the middle picture, then both the observer and the standby database will lose connectivity with the primary. First, like the observer will like try to reconnect. And if there's still no response from the primary, after a certain prefixed time, then the observer will start the failover process, like failover to the standby database. It will first verify like that the standby is ready to failover to become the primary database, and then the failover process will happen. And what that means is basically the standby will then be open to read and write, and it'll become the primary database. Once that happens, like users and applications can then use it. And after the failover, like when the connection to the former primary database is reestablished, it could be automatically reinstated as a standby database, like we see in the last picture. I just want to add a note that like there is a process called switchover, which has similarities to failover, but there are some differences. A switchover is also a role reversal between primary and secondary database, but switchover guarantees no data loss, whereas failover may result in some data loss. And switchover is typically done for planned maintenance of the primary system, whereas failover, it's usually performed when there's like a catastrophic failure of the primary database. Okay, so we move on to database recovery, and we will see failover work here as well. So what do we mean by recovery? It's restoring the database to the most recent consistent state that existed shortly before the time of system failure. So like, unfortunately, like the hardcore truth is your stuff will go offline. Your servers will die, and users will still expect the data to be always available. So today we'll touch a bit on like disaster recovery, and to do so, we'll also briefly talk a little bit about high availability and disaster recovery, aka HA and DR. So high availability, the HA, has to do with a downtime problem. If something goes down, you want it back up as quickly as possible. You want to decrease the recovery time. So HA is about minimizing or even eliminating downtime. And disaster recovery is about how much data loss you can tolerate. Of course, you want to minimize the data loss as much as possible. All right. There are a number of HADR solutions for SQL servers, like including what we see here, like from the most basic, like backup and restore to lock shipping to SQL Server failover cluster instances, it's a mouthful, database mirroring, and so on. In the interest of time, we'll just talk about lock shipping today. So say we have two databases. Okay, the live or the production database is in one location, and a duplicate of that server or database is in another location as a standby. The live one will process the transactions. It will respond to queries, and more importantly, it will build transaction logs. And then on a periodic basis, it will send or ship the latest transaction logs to the standby. So the standby will then ingest these logs, and it'll bring its own database in sync with the live database. How frequently this occurs, it'll depend on how busy the database is and what are the recovery requirements. For example, like slower database logs will send, like say, once per hour, whereas in faster databases, it could be once every 5 minutes. So yeah, if something goes wrong with the production database, we can take steps to failover to standby database, ensuring that the production database is down and off the network, and then switch the standby to production mode. So this is log shipping. And yeah, with that, we've come to the end of my talk. As I was saying earlier, like we barely just scratched the surface with these concepts today. If anyone wants to discuss any of these topics in more detail, just feel free to reach out to me. Yeah, thanks, Anthony, for your question. That's all, folks. Here's my contact info. Thank you all for coming to my talk. I'll see you again later.